Hi, my name is Stephen Machek, and my project is entitled The Potential Synergistic Effect of Combined Blood Flow Restriction Training and betaine Supplementation on Skeletal Muscle Mechanotransduction-Associated Cell Signaling and Commensurate Hypertrophy. So as the title of my project would imply, the idea is that both blood flow restriction or BFR training and betaine supplementation might act synergistically to create a greater hypertrophic scenario than either of the individual constituents. This is based on the idea that both of these different ergogenic modalities are potentially mechanistically sourced in their effects on cellular hydration, whereby the former relates to its potential effect on blood pooling distal of the partially arterial occluded site, so where the tourniquet is located, or cuff for that matter, which can induce the scenario of extra to intracellular fluid flux due to the hypotonic scenario in the muscle that is exercising, which ultimately can increase the passive tension within the muscle via that increase in fluid. So betaine, on the other hand, which is a kind of up-and-coming supplement in the sports nutrition area, is not only noted for having scenarios of more optimal body composition, but also a greater degree of muscular endurance. And this might be potentially because of its effects as an organic osmolyte, which not only act kind of similar to stress proteins, but also can increase the basal levels of hydration within the cell. So the idea is that potentially these two together can work synergistically to actually increase both the passive and the active tension within the muscle, largely being caused by this increase in extra to intracellular fluid flux, as well as a greater degree of stability in response to metabolic stress because of the betaine supplementation. So ultimately, can these two increase growth signals within the cell? So some of these key growth-related intracellular targets are the upstream and downstream targets of the mTOR pathway, the ERK1/2 pathway, and focal adhesion kinase, which is a little less talked about, but associated with mechanotransduction and integrin signaling. So we wanted to test this by doing a placebo-controlled, crossover, counterbalanced, and ultimately randomized when possible design by employing 12 males between the ages of 18 to 35. We're going to give them either a betaine or placebo supplement for 14 days in the dosage of 6 grams per day. They're going to come in after 12 days of supplementation to test a 1 repetition maximum on both legs on a seated leg press. They're going to continue their supplementation for 2 more days, also tracking their diet and avoiding exercise. Then they come in for their first testing visit. So during that visit, we're going to do a multiplicity of different tests on them. So they're going to have biopsies taken from their vastus lateralis. We're going to collect blood. We're going to get toe lactate at multiple time points, and we're going to be checking their hydration using BIA, or bioelectrical impedance analysis. So the time points at which we're going to be testing them are before leg press exercise, immediately after, 30 minutes after, and 3 hours after. The legs that are going to undergo this training are going to be randomized to either a high-intensity, kind of quote-unquote standard resistance training group at 70% 1RM, as well as a low-intensity occluded BFR group at 30% 1RM. They're going to have 4 sets that are standardized, and they're going to have 2 sets to failure. So ultimately what we're going to be looking at is we're going to be looking at protein phosphorylation of all those different growth targets that I mentioned previously, as well as we're going to look at both serum and muscle betaine in order to determine if that betaine supplement is actually facilitating a higher degree of cellular hydration, or kind of mediating some of these positive impacts on kind of attenuating hypotonic stress during the exercise. We're also going to look at genes related to anaerobic metabolism, including myosin heavy chain changes that might be occurring, hypoxia-inducible factor 1 alpha, the alpha isoenzyme of lactate dehydrogenase, and the betaine transporter enzyme. Lastly, we're going to be looking and assessing hydration using hematocrit, BIA, and changes in wet to dry tissue. So because this study is exploratory in nature, we wanted to test the null hypothesis. Firstly, we assume that we're going to see equivocal findings when it comes to our phosphorylated protein targets and hydration. Second, we don't expect to see any significant differences between the different groups when it comes to gene expression. And lastly, we expect to see relatively similar load volumes accumulated between the different groups, except we assume that betaine and the placebo groups will actually have the greatest load volume between any of the different conditions, but no differences between one another.